So today I am here with lecture 6, right? In lecture 6 we are going to discuss one more application of Gauss law, right? As you know, in last class I discussed with the help of Gauss law we are able to calculate electric field, right? So now one more application we are going to calculate electric field, right? Electric field due to thin spherical cell, right? Electric field due to thin spherical cell, right? So electric field due to thin spherical cell, okay? So consider, so see, this is your thin spherical cell, right? Okay, and charge is distributed over this disk, right? So these are the charge which is distributed over this thin spherical cell, okay? And we have to find electric field due to this cell, right? So consider a thin spherical cell having surface charge density sigma, right? So this is your spherical cell, right? And having surface charge density sigma, okay? Let us calculate electric field. Let us calculate electric field at a distance r from the center, okay? R from the center, okay? So we have to find electric field due to this thin spherical cell, right? At what distance? At r distance from center, right? So in this condition, basically three cases possible, right? In first case, we are going to find electric field outside the cell, okay? And in second case, we are going to find at the surface, right? And in last case, inside the cell, right? So basically three cases we are going to discuss. Let us calculate electric field at a distance r from the center. First one is outside. Second one is at surface, and last one is inside, okay? So only these three cases possible, right? So this is your cell, surface charge density is given, right? And we have to find electric field outside, at surface, inside, right? So first I am going to deal with this one, right? That means outside, right? So outside, first we are going to, outside means we are going to find electric field outside the cell, okay? Outside the cell, okay? So suppose this one is your cell, right? Thin spherical cell, right? Okay? And we are going to find electric field outside, right? So if we are going to find electric field outside, we have to construct a Gaussian surface outside this one, right? So this is your Gaussian surface, right? Okay? Suppose this surface is at r distance from the center, okay? This surface is at r distance from the surface, right? So as I told you, I am going to calculate electric field with the help of Gauss law, right? And Gauss law is what? Gauss law is phi net is equal to Q in by epsilon 0, right? Q in is charge inside this Gaussian surface, right? And phi net is flux passing through Gaussian surface, right? So to calculate electric field, first we have to find flux, right? How much is the flux? Okay, so you can see here electric flux, electric flux phi is equal to, now again you can see here direction of electric field line is changing. Here direction of electric field is in this direction, right? Here is in this direction, right? So direction is changing, right? So we have to use integration, right? Integration we have to do like this: E dot ds, and ds is what? Ds is a small surface. Suppose this would need your a small surface, right? So on this small surface electric field is in this direction, right? And area vector is small ds. Ds is also in this direction, right? Both is along same direction, so angle is 0, right? So further we can write here integration of E ds cos 0, right? Cos 0 is 1, right? Now see, now this is magnitude of electric field, right? All the point which is lying on Gaussian surface at equal distance from the center, right? So E will be constant, right? So we can take it out. Okay, so I'm taking E out. So what value you have? So inside the bracket you only have integration of ds. Cos 0 is 1, right? And now further we can write here integration of ds is what? S. So E into S, and S is total surface area of Gaussian surface, right? And total surface area is how much? This is in form of a sphere. So surface area of a sphere is 4 pi r square, right? So now one thing is done. I calculated pi net, right? Next we have to find Q in. Q in is charge inside the Gaussian surface, right? Charge inside the Gaussian surface, charge inside the Gaussian surface, that means charge inside the Gaussian surface means what? Charge inside the Gaussian surface means what? Charge at the surface of the thin cell, right? Yes or no? Yes or no, right? So now you can see here, charge is how much on this one? Surface charge density is given sigma, right? Sigma is given, right? And suppose this cell is having radius capital R, right? So total charge on this cell, how much? Sigma into area of this thin cell, right? Thin spherical cell, and that is how much? 4 pi r square. I am taking here capital R because we have to charges. Where charge is present where? On this thin spherical cell, right? So that's why I am taking 4 pi r square. Okay, Q in is known, this one is known. Now again by substituting the value in this formula we are able to find electric field, right? Okay, so now you can see here, from here we can write. So again I am writing here according to Gauss law. According to Gauss law. According to Gauss law. What is Gauss law? Phi net is equal to Q in by epsilon 0. Phi net is calculated, right? Phi net is calculated. So I am just substituting the value, okay? So after this I am writing, after this you can write from here, right? So phi net is according to Gauss law, final is equal to q in by epsilon 0, right? Final is calculated. This is your final. So I am substituting the value E into 4 pi r square, right? 4 pi r square, and again q in. This is your q in. Q in is sigma by 4 pi r square, and in denominator what will come? Epsilon 0, right? Now you can see here what things are 4 pi. 4 pi is cancel, right? 4 pi is cancel, right? So what value will come here? What value will come? E is equal to sigma capital R square by epsilon 0 small r square, right? So this is your formula to calculate electric field due to a spherical thin cell, okay? Now one more form of formula is also possible, right? Suppose if we are going to substitute value of sigma, right? If you are going to substitute the value of sigma, then another formula will come, right? So any one formula you just remember, no need to worry about. So this is one formula to calculate electric field outside a thin cylinder, right? Outside a thin cylinder, okay? Now you can see here what formula, this is your formula, right? Suppose I am going to substitute value of sigma, right? Okay, so now you can see what I got. This formula I got, okay? R square pi epsilon 0, right? And here you know sigma is what? Sigma is equal to q by sigma is equal to q by 4 pi r square, right? Surface charge density, the charge per unit surface, right, is known as surface charge density, right? Now we are going to substitute value of sigma in this formula, right? Now you can see E is equal to sigma is how much? Q by 4 pi r square. Just I substitute the value of sigma, right? And now what is the remaining term is present? R square is present, right? And this is also present, right? Epsilon 0, right? Okay, now you can see here, and r square, small r square is also present. Now you can see here, this r square is cancelled by this r square, right? So now further you can see 1 by 4 pi epsilon 0 q by r square, right? And you know 1 by 4 pi epsilon 0 is k, right? So further we can write here E is equal to kq by r square, kq by r square. So this is your another formula to find electric field outside a thin spherical cell, okay? So note it down, okay? So next I am going to find electric field at the surface, right? So second one is B. In B we are going to find at surface, right? So at surface, right? At surface R, small r is equal to capital R, yes or no, right? Small r is equal to capital R, right? So formula at surface, what will be the formula? Small r is equal to capital R, right? So first from this formula you can write sigma r square, right, by epsilon 0 r square, right, from that formula, right? And this r square is capital R, right? So r square cancel, right? So what value is coming? E is equal to sigma by epsilon 0. So this is your value of electric field at the surface of thin a spherical cell. Okay. Now, suppose I am going to use this formula, right? So, using this formula, we can write here. You can see here, kq by r square, right? Here r square, small r is here, right? And small r is equal to capital R, right? So for formula will be, okay. So this formula is useful to surface, right? Surface of cell, okay. So next we are going to find last one, that is inside, okay. Inside, right? So again we have to draw a spherical cell. This is your cell, right? And this is center, right? And now we are going to find electric field inside, right? So we have to draw Gaussian surface inside the surface, right? So see, this is your Gaussian surface. See, this is your Gaussian surface inside the surface, right? Here. And this Gaussian surface at what distance? Smaller, right? Now you can say here, how much is the value of flux? Flux will be same, right? How much? E into 4 pi r square, okay? 4 pi r square, right? And what is the charge inside this Gaussian surface? 0. There is no charge inside the surface because all charge on the spherical cell, surface of a spherical cell, right? Where is all charge? Charge on the surface of a spherical cell, right? So there is no charge inside this Gaussian surface, right? So for this one, Q in is 0, right? As Q in is 0, that means Q in is 0 and electric field is calculated. So according to Gauss law, right? What is that Gauss law? According to Gauss law, we can write again finite is Q in by epsilon 0, right? Q in by epsilon 0, okay? Yes or no? Yes. Now, finite is how much? E into 4 pi r square, okay? And Q in is 0. Just see, Q in is 0 and this is your epsilon 0. So further we can write here E is equal to 0 by 4 pi r square epsilon 0. So 0 divided by something value will be 0, right? So 0. So electric field is how much? Electric field is 0. So inside the spherical thing, say electric field will be 0, right? Okay. So now I'm going to draw graph between E versus R, right? Graph. Okay. So just see graph of E versus R. Graph of E versus R, right? So suppose I am taking electric field on y-axis and on x-axis I am taking R, right? Okay. So as you know, inside there will be no electric field, right? So as we are moving in this direction, right? As we are moving in this direction, electric field is 0, right? 0. At some value R equals to R. At some value R equals to R, electric field becomes how much? E is equal to KQ by R square. So now this is your point, R is equal to R, and here electric field is how much? KQ by R. For R, see in this region R is smaller than capital R. Small r is smaller than capital R means what? Point is inside the surface, right? If inside the surface electric field will be 0, that means there is no electric field. But suddenly at R equals to R, electric field becomes KQ by R square, right? So here electric field is how much? So at this point electric field is this much, right? But what about in this region? What about in this region? In this region, R is small r is greater than capital R. Yes or no? Right? So greater than, and that means in this region, point is outside the surface, right? So what is the formula for point outside the surface? You know the formula, right? Okay, so electric field outside, right? What is the formula for electric field outside? This is formula, right? Sigma R square by epsilon 0, right? You can see here this value is a constant, right? And this value is constant and this is varying. At point is changing, this value will change, this value is not going to change, right? So from here we can write, E is inversely proportional to R square, right? So E is inversely proportional to R square, so graph will be somehow like this, right? So you can see in this region electric field is 0. At this point electric field is constant, and that constant is how much? KQ by R square, and in this region electric field is varying inversely proportional to R square, right? So this is your graph of E versus R, right? Okay, R is the distance of a point from the center of a spherical cell. Okay, so this is all about your electric field due to a spherical cell. Okay.